Some equations arising in engineering and scientific applications. In many scientific and engineering applications that you will meet when you study these subjects, the dependent and independent variables represent physical quantities, perhaps time, speed, voltage, current, chemical concentration, and so on. Often these physical quantities are related and can be expressed mathematically through a straight line relationship. In the remainder of the course, we will introduce some typical examples. The first example that we will look at is called a distance time graph. When an object, perhaps a car or a bicycle, travels along a road at a fixed, that is a constant speed, the distance it's travelled from its starting point obviously changes as time increases. It is possible to use an equation to calculate the distance travelled at any later time. Suppose we let t represent the time and s be the distance travelled in that time. Suppose the fixed speed of the car or bicycle is u. Then it is possible to show, using some basic laws of physics, that distance and time are related by the equation s equals u times t, or more simply, s equals ut. The variables in this problem are s and t. The speed u is fixed or constant. The distance travelled s depends upon the time. So s is the dependent variable and t is the independent variable. Now that we are dealing with physical quantities, a consistent set of units of measurement must be used. We shall assume that time t is measured in seconds, distance s in meters, and speed u in meters per second. A graph of s plotted against t using the equation s equals ut is a straight line graph known as a distance time graph. A typical distance time graph is shown here. The distance s is plotted on the vertical axis and the time t is plotted on the horizontal axis. In the equation s equals ut, note that the coefficient of the independent variable is u. Consequently, if we compare s equals ut with y equals mx plus c, we can tell that the slope of the graph, m, must be the speed u, and the vertical intercept of the graph, c, must be 0, and hence the graph passes through the origin. So what does this graph tell us? Clearly the straight line passes through the origin. This means that when the time t is 0, the distance travelled s is 0 too. After 4 seconds have elapsed, the distance travelled is 2 meters. See for example the point A, 4, 2 on the graph. After 10 seconds, the distance travelled is 5 meters. We can see this by looking at point B on the graph. We can discover other information from the graph. After 1 second, the distance travelled is half a meter. In other words, the speed, which remember is constant, is half a meter per second. So you see a distance time graph can capture more useful information in addition to just distance and time. For this graph, u equals a half. And so the equation of this line is s equals a half t.